Here I have prepared 4 different test tubes with water, and for each of the experiments I'm going to use 5 milliliters of water and 1 gram of each of the solid to dissolve. The initial temperature of the water has been measured to be 27 degrees Celsius. Let's write it down there. 27 degrees Celsius is our initial temperature. We will start with dissolving ammonium nitrate. The lowest temperature is measured to be 20 degrees Celsius. The second reaction will be between calcium oxide and water. 1 gram of calcium oxide in 5 milliliters of water. Let's measure the temperature. The temperature to measure is either the maximum or the minimum temperature reached. The highest temperature is recorded to be 32.5. Next one is dissolving calcium chloride in water. The highest temperature recorded is 35 degrees Celsius. The next reaction is between sodium hydrogen carbonate and citric acid. Any carbonate reacting with acid will produce carbon dioxide, and if it's in solution, you can see the bubbling or freezing happening. The lowest temperature recorded here is 15. The next reaction is between hydrochloric acid and sodium hydroxide. Initial temperature remains the same, 27 degrees Celsius. And for each of these solutions, I use the same concentration of 2 molars and approximately 3 centimeter cube of solution. The maximum temperature recorded is 37 degrees Celsius. The next reaction is between calcium nitrate and sodium carbonate. There seems to be no temperature change. Sometimes, if there is very little energy exchange in the reaction, we may not be able to detect any change in the temperature when we are dealing with reactions of dilute solutions. So we are still at sodium carbonate and calcium nitrate. I'm going to try if I can detect any change in the temperature when I mix the two solids in just 5 ml of water, because that way the concentration will be high enough for me to read the temperature change. The lowest temperature detected is 26 degrees Celsius. The next experiment is on sodium metal. So I am required to react sodium metal in water, but let's just take a look at a few properties of sodium metal. Because it is so reactive, it will readily react with water vapor or oxygen in the air. And that's why sodium metal is stored in oil. The oil cuts off the access to any water vapor or the air. And sodium is a metal, but you can see here it looks white. Typically, metals are silver or gray color, like the color of my forceps here. But if you cut this, you'll see that on the inside, sodium actually looks lustrous, looks gray or silver, just like any other metal. The reason why it looks white on the outside is because it reacts with oxygen in the air to form sodium oxide, and sodium oxide is white. Notice how easy it is for me to cut sodium. Sodium is a group 1 metal, and group 1 metals are soft. It's like cutting frozen butter. Let's put some of these back in the oil. I'll just use one piece. Before we start the reaction, I'll add phenolphthalein indicator into our water. This time I use 10 milliliters of water. Phenolphthalein indicator is clear colorless below the pH of 8.5, but pink above pH of 9. So now the color of distilled water is clear colorless because pH is 7. Thermometer ready. The sodium metal. You can see that the sodium metal actually floats on the surface of water and it forms a ball. You can also see fizzing, very vigorous fizzing happening, and most clearly you see that the color of indicator now turns pink, indicating that the pH is above 9. Because sodium hydroxide is produced, and sodium hydroxide is a strong base. And the fizzing is a result of hydrogen gas being produced in the reaction. The highest temperature recorded is 30 degrees Celsius. Before you watch this part of the experiment, please pause the video and predict whether sulfuric acid and potassium hydroxide solutions will react in exothermic or endothermic way, and give your reason why. For these reactions, I use 2 molar of sulfuric acid and 2 molar of potassium hydroxide, and I use 3 centimeter cube of each solution. The highest temperature detected here is 33 degrees Celsius. Reactions that causes a decrease in temperature are endothermic reactions because energy has been taken in by the system from the surrounding, so the temperature of the surrounding decreases. But reactions that causes an increase in temperature are exothermic because energy has been released by the system into the surroundings, so the surrounding temperature is increased.